It started like a normal day until 50% of order failed. The CEO calls. He needs answer now. Errors everywhere. Joya from analytics team want real-time insights. But the database is choking and Slack is blowing with messages, alert and panic. Everyone is asking, where is data? This is where data engineer shapes the day. In this video, we will build two pipelines, one batch and one real time, just like it happened in the real world. Stick around. By the end, you will know how to build it by yourself. Hello everyone. Now let's see it all in action. So we talked about what data engineers do, from building a pipeline to keeping data clean, because theory is cool. But how does data engineering actually look like in the real world? How does it fit into the architecture of modern app? Like, let's say, an e-commerce application. Well, that's exactly what we are diving into today. A real world end-to-end data pipeline example with a real use case and just enough technical detail to make you, oh, now I get it. Let's go behind the scene of how data flows through a real system and why data engineering is the backbone of everything from analytics to AI. Let's assume we are working with an e-commerce application, a platform where we sell product online. Now, Joya from the business analytics team comes to you and says, "Hey Mr. X, you know what? Yesterday something weird happened to our platform and more than 40% of order has failed due to some technical glitch in the application, and at the same time some of the product were out of stock in our inventory. Now our CEO want to create us a dashboard to monitor some KPIs. KPI that Joya needs in the dashboard is something like this: total number of sales for the day broken down into status, something like successful, failed and in progress sales. A list of product with 5 or fewer items left in the inventory so we don't go out of stock unexpectedly, and a list of trending products based on the seasonality and other trends. The ones people are loving so the inventory team can overstock those items and we do not miss sales opportunity. Joya then adds, the analytics team is ready to build the dashboard, but we need the data. Can you think about it and design a solution to get this data in place so data analytics team can start building the dashboard? So, as the data engineer on the team, how do you make this happen? Now take a moment, pause and think. If you were to build this, what would your approach be? Based on your current knowledge of software engineering or even just a common sense, where is this data likely to come from? What step would you take to gather the data, process it, and make it ready for the dashboard? This is a great opportunity to start thinking like a data engineer. So let me help you and we will break it down step by step and design the data pipeline that powers this dashboard. Alright, let's put our product engineer hat for a bit and take a closer look at how our e-commerce application might be structured, how it functions, and most importantly, how data flows to get stored behind the scenes. This is what a typical modern application architecture look like. A client, usually a web application or a mobile app that user interacts with. In our case, this is a mobile app, the e-commerce application from which a user orders the product. Once the order is placed from the application, the request for the order land into the API gateway. So now what is API gateway? API gateway acts the front door receiver for the request, receiving the request from the client and routing the request to appropriate microservices or services. You can think of API Gateway as something like a security guard in tech parks and trends who guides employees to respective companies' building. The same way API Gateway also works. When you say, hey, I want to create an order, API Gateway routes you to order service. When you say, I want to update the inventory, it routes you to the inventory service, and so on. Hope it makes sense. But before routing to the appropriate service, it asks the authentication layer whether you are authorized to access the service or not. And authentication layer verifies whether the user is authorized to access the service or not. It's like the security guard in your office reception who does not allow you to enter the office if you are not an employee of that company. As simple as that. Once authentication is done, the request reaches to the backend application or a service where all the business logic gets performed, like checking stock availability, storing your request to database, and intimating the inventory team to parcel your product, and of course payments. Once the request get completed in the backend application, the final data is updated in the database. Like sales tables get updated with all the information, inventory tables updated with new stock for the product that you had ordered, and so on. This is how a typical day modern application looks like. Let's come back from the software world to the data world. Don't get lost there because we are trying to build data pipeline, not an e-commerce application. So the question remains same. How do we solve the requirement that Joya had just dropped on us? You are probably thinking, well, this requirement is urgent and the CEO wants us to build this dashboard as soon as possible. And you must be thinking, hey, wait a minute. We already have all the data in our application database. Why not just let the analytics team plug in a BI tool like Metabase or Tableau directly into it, run some queries, and boom, dashboard is done. You are thinking that, right? And honestly, it's not a bad thought. But here is the catch. The solution is not scalable, not even close. It might work fine right now with a small use case and light traffic, but what happens when your platform starts growing? Let's paint the picture. Imagine this. You are running a large scale e-commerce platform with millions of users and millions of transactions every single day. Now look at the sales table inside the application database. Can you imagine the size of table? How much data will be stored in that single table? It would be massive, right? And now let's say you are trying to solve the Joya's third requirement, creating a dashboard for showing a list of all trending products based on the seasonality and purchase trends. To create the single dashboard, you need to run the full scan of the table. Probably you need to join with other tables like product, user, inventory, and maybe even the marketing campaign. That's already a heavy query, right? Now imagine this query is being run every 5 minutes to refresh a real dashboard. That's a full scan repeatedly, and that's just one use case. And now assume your CEO want more observability on what is happening with other processes. Joya wants you to add dozens or maybe hundreds of other dashboards. Now you need to run hundreds of such analytical query running in parallel. Do you see the problem powering the dashboard directly from the application database? Yes, there is some problem. If we power the dashboard directly from the application database, the load on the application database becomes unbearable. Performance of the database drops. That leads to a performance drop in our application. The real-time app starts lagging. In worst case, the system crashes completely. And guess what happened next? Joya comebacks at your desk, this time with maximum sarcasm, and she tells you, were you solving a problem or creating a new one? This is where data engineers step in to design scalable, reliable, and performance-friendly data system. to offload analytics from the application database, to create proper pipeline models and warehouses, to make sure the business can grow without bringing the whole system down. Pretty interesting, right? Okay, now it's clear that we cannot power the dashboard from the application database, and we have to move this data to some reliable and more performant system that is designed for running analytical query. In the other words, which is designed for scanning huge data without much performance degradation. For time being, let's call this new database where we will be storing the data at Zoya's database, just for fun. But with this, another question arises. Okay, we need to move data to Zoya's database, but how frequently do we need to move the data? Will moving data daily be good enough? Or maybe twice a day? Or hourly? Confused, right? Alright, let's take a closer look at the Zoya's requirement and ask a simple but critical question. Do we need to move this data in the Zoya's database in real time? Can we afford a delay? Maybe minutes, hours, or even a day? Because the answer to this question determines whether we build a real-time pipeline or batch pipeline to move data from application database to Zoya's database. To find the answer, let's look at the requirement. Requirement number 1. We need a dashboard showing total number of sales for the day, broken down by status like success, failed, and in progress transactions. Now remember why we are building this. 50% of order failed in a single day, that's huge. The CEO is worried. Zoya wants the dashboard to catch the issues as soon as they happen. The CRM team might want to reach out to customer quickly, maybe even recover the sale. So yes, this is absolutely a time sensitive use case because the CRM team needs to reach to the customer as soon as the sales order fails to recover the sale. If CRM reaches 1 day or 1 hour late, customer might buy the product till then from some other e-commerce platform. So definitely this use case is a time sensitive one. We should build a real-time pipeline here using something like CDC, Kafka to stream order data continuously in real time. That means as soon as the sales order failed and failed transactions stored in the database, we need to move this data to Zoya's database immediately. Let's move to requirement number 2. We need a dashboard showing a list of all the product with 5 or fewer items left in the stock. Now, is this important? Yes, this is important. But do we need to update it every second? Probably not. If we update the dashboard every few hours or even once a day, that's still good enough for the inventory or warehouse team to take action and restock the product. So this is a semi time sensitive but still totally fine to handle with a batch pipeline. Let's look into requirement number 3. We need to create a dashboard showing a list of all products that are trending based on the seasonality or other trends. To calculate trends, you often need to aggregate days or weeks of data. Run statistical query or ML model and compare against the past season. So honestly, even a daily update is more than enough here. This is a classic batch analytics use case perfect for overnight pipelines. This is exactly how data engineer thinks, matching business time sensitivity with the right pipeline design. Okay, so now it's clear we need two pipeline, one for requirement 2 and 3. It will be a batch pipeline and other one for requirement 1. This will be a real-time pipeline. Now let's build both versions so you get the full flavor of data engineering pipelines. Alright, let's build the batch pipeline for the Zoya's second and third requirement for showing low latency product and trending product. And well, do it the way many real world teams get started. keeping it simple, practical, and easy to understand. As usual, we will start from the step 1 data extraction. We will write two small Python scripts. This script will connect to the application database, run some queries, and push the raw output into the landing zone, like a folder in S3 in JSON format. First script is for requirement 1 for low inventory. The script will query data from the inventory table for products with 5 or fewer items left in the stock. Second script is for requirement 2 for trending products. We will keep it simple for now and we will assume that the top selling product the last 7 days is trending product. So this script will query the top selling product from the last 7 days. Now these two scripts are scheduled to run every hour using Apache Airflow, each one inside its own DAG. Think of DAG as automated pipelines with steps that run on schedule. So data is now getting extracted every hour for low inventory and trending product. We will next move to the step number 2, that is data transformation. Once our data is sitting in the landing zone, it's time to clean it up. Again, we will use two scripts, one for requirement 2, low inventory, and another one for requirement 3, trending products. Each of them doing simple but essential tasks. Reading the data from landing zone in JSON format, removing duplicates, dropping null values, formatting timestamp properly, standardizing things like currency and category labels. After the transformation, the clean data gets stored in the curated zone as a delta table, where it's structured, analytics friendly, and ready to be picked up by the BI tools. This transformation script are also part of the same DAG and run after raw data is dumped. So everything flows in a neat and dependable order. Every 1 hour, DAG runs and trigger the step 1 of the DAG. Step 1, extract the data from database table, store it in landing zone as JSON, and triggers the step 2. Step 2 queries the data from landing zone, do some transformation, and store the transformed data into curated data layer as delta lake. From curated zone delta table data, analytics team can query the data and create dashboard. This approach works great when you don't need real-time data but still want fresh and accurate insight updated every hour or maybe even just once a day. Low inventory alerts you can check and restock every few hours. Trending products, that's based on a week of data anyway, so again a delay of few hours is acceptable. And the best part, this whole setup gives us taste of real world pipeline structure like landing zone, from landing zone to transformation, transformation to curated zone, and from curated zone to data analytics. So that's your batch pipeline in Excel. Joya gets her dashboards, the system stays stable, and your data flows smoothly like a well-oiled machine. Let's solve the real-time challenge, Joya's requirement number 1, and show how a powerful data engineering pipeline can save the day using tools like CDC and Kafka. Are you ready? Let's go. Now that we have seen how batch pipeline work, let's switch the gear, tackle the Joya's requirement number 1, the most urgent one. Total number of transactions for the day broken down by success, failed and in progress transaction. Why is this requirement time sensitive? Because 50% of the order failed in the single day and now CEO wants a dashboard that reflect this data in near real time. So the CRM team can jump in fast and recover those failed orders. So yes, this is clearly a real-time use case. Batch processing every few hours or once a day won't meet the requirement. Now let's design a real-time pipeline that handles this. Here is what we will do. And this is very common approach used in modern data architecture. Step 1. Capture data change in real time. Instead of pulling data periodically like we did in the batch, we now want to capture changes as they happen. And for that, we will use a technique called Change Data Capture, CDC. We will set up a CDC tool like Debigium to monitor the application database, especially the order table. Every time a new order is inserted or its status is updated, success, failed, or in progress, Debigium capture that change. It immediately streamed this change to Kafka topic. So now, no need to query the database repeatedly. We are getting the real-time updates as soon as something changes. Once data is extracted from database and moved to Kafka, let's look into the step number 2, stream processing and transformation. Once the data change are flowing into Kafka, we will need something to process and save the stream. We will use stream processing tool like Kafka Stream, Flink, or Spark Structured Streaming to read the order event from Kafka, apply lightweight transformation like converting timestamp, filtering nulls, mapping status to human readable terms, maintain a running count on daily transaction by status, success, failed, or in progress. This process data then published to a new Kafka topic. Think of it as your real-time transformed stream. Once live transaction data based on status is streaming in the Kafka, let's look into step number 3. Load into analytics store or dashboard or cache. Now that we have clean real-time data, we need to make it available for dashboard. There are two common options here. First one is push the process data into real-time analytics store like Apache Druid, ClickHouse, or a streaming warehouse like Snowflake. Or option number 2, cache it in low latency data store like Redis or Elasticsearch that powers the real-time dashboard. Either way, your analytic team will now have live data at their fingertips, ready to be visualized in tools like Metabase, Power BI, or a custom dashboard. See the difference. Compared to the batch pipeline, here we are not waiting around. We are reacting to the events as they happen. That's the power of real-time pipeline. Joya gets her dashboard instantly updated. The CRM team can recover failed order faster, and CEO, he is super happy. And you, my friend, just saved the day again. Alright, that's it for this video. We explored both sides of data pipeline world, batch and real time, and saw how you as a data engineer can design solutions that are both powerful and practical. Hope you are feeling little more like a data superhero now. Wait, now you must be thinking, wait a minute, what about the actual coding? We just talked the theory, right? Don't worry, that's totally intentional. We are laying a solid foundation first, so when we dive into the code, everything will be actually making sense. You will know what you are building and why. And I promise, as the course progresses, we will bring these pipelines to life, both of them, the batch pipeline and the real-time pipeline. We will build them step by step for real by the end of this course. I'll see you in the next one where we take this knowledge even further. Till then, stay curious and keep building cool stuff. Bye for now.